Hello, guys. Welcome to the workshop. I'm really looking uh, forward to us working on a quite interesting problem statement. So, before we jump into clustering, I'm going to talk a bit about KNN, which will serve as the basic algorithm for k-means as well. So, we'll be looking into KNN and k-means clustering. So, KNN algorithm can be used in both classification and regression. So, let's quickly jump into the slide. Yeah, so this is me, and I'm a master student. I'm doing my majors in computer science, and yeah, I'm Pooja. And right, currently my research focus is computer vision and reinforcement learning. So if you guys are interested to know anything more about that, feel free to reach out. Okay, so what is KNN? KNN is nothing but K nearest neighbors. So we're just going to find out who, to a specific point, how many people are close by. So that is the basic idea of what KNN is. It is a classic machine learning algorithm, and it is a supervised learning. So supervised learning is basically we'll be feeding in the data, and the a model will learn the data, and that's how classification regression happens. So that is supervised learning. And basically, yeah, so birds of the same feather flock together. That's the idea of KNN. So like I said, KNN is a supervised machine learning algorithm. It's used for both classification and regression. What it does is that it takes a new point and see who are like the closest point to it. And depending on that, it'll take a decision. That's basically what KNN does. So the distance, we measure it using certain formulas, which will be which we'll discuss in the coming slides. And we'll find the nearest points to the specific point. So yeah, so for regression, we take the mean of those points, and the mean would be the prediction of the test point. And for classification, we take the mode, and the label of that specific class would be the output of the classification. So so this is the new test point, and this is category B, and this is category A. So what we do is basically let's take a k value of 5. So it chooses the 5 closest neighbors to it, and it checks the distance from each individual point. So from here we can yeah, yeah. So from here we can see that 3 of them fall into category B, and 2 of them fall into category A. So we'll classify the new test point as though it belongs to category B. So that's basically the general idea of how the algorithm works. So let's get into the properties. First thing is that this is a memory-based learning or an instance-based learning. So what it does that it memorizes all the training data. What I mean by memorize is that it takes all the training data into consideration and computes the distance of all the data. So that is the first property. The second property is that it's a lazy learner. So lazy meaning the usually in machine learning algorithms, all the learning happens during the training phase. But there's the only algorithm where the learning does not happen during the training, but during the testing phase. That is, only when the new data point is introduced, that's when all the distance calculation with the data point happens. So all that learning phase happens during the testing time. That's why it's called a lazy learner. And the last property is it's a non-parametric learner. Meaning, if you've like learned about linear regression and everything, you have all these ax plus b kind of values where the model will try to learn what a and b values are. So this is nothing of that sort. So it's a non-parametric learner. Next, we'll get into the actual algorithm of how the KNN works. So first thing that it does is it calculates the distance between the test point and each data point in the data set. And it's like, so let's say this is the test point and blah, 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 data points are there. So this calculates the distance between everything and forms into an ordered list. So, or a dictionary, list or dictionary. So list in case of regression and dictionary in case of classification, where we'll have the label to distance. Yeah. So this is how it'll be. And the next step is that it will sort. So once it sorts, we can find the k nearest neighbor points. So once it sorts, the first 5 or the first k points will be the nearest neighbor. And based on that, this dictionary or this list, we'll make predictions. So how do you find the correct k value? That is the most important part of this algorithm. So One thing is that, like I said in the beginning, it is calculating mean and mode. So for this, it is easier for it to be an odd value, where the calculation of mean and mode makes a little bit has a little bit more clarity. So that's one thing. The next thing is, you have if you keep the value of k to be very low, as you can see here, it overfits the data. It includes all the noise into the data. Let's say, like for example, take this point. So these are points, and these can be noises as well. So if you try to fit a model to it, it learns all these noises also. So that becomes very clumsy. So we are not supposed to select a low value. Okay, then for a safer bet, can we take a high value? That is also not possible. If you take high value, it neglects all the information points also, and it will form a very random curve, right? So in that case, we will have it'll get underfitted. So choosing correct k value is very, very important. So how are we going to achieve that? We'll do it with the concept of elbow method. So what we do is that uh, I don't know if you know about cross validation. So we'll basically split the data set into k subsets, which will have k minus one training set and the one testing set. So the data will be split into k such sets, and we can. Sorry, did you have any question? Okay. So yeah, and we can have the k range to be 1 to 10. Okay, and these can be the error values. So when you take k to be 1, the error can be somewhere here, and k to be, if you take it to be 2, the error can be somewhere here. Like that, you can draw the graph, and the graph will somewhat look like this. So this is the optimum k value. How do we find that? Is basically, with every increasing k, here you can see a major difference, but here the difference is very, very less. So beyond this, the data overfits, and before this, the data underfits. That's how you get this k value. Any doubts so far? Cool. Okay, distance metrics. So, like I said, this whole algorithm basically depends on the distance between 2 points. So there are first type of distance is Euclidean distance, which we have all basically learned. This is 0.1, this is 0.2. So x2 minus x1, sorry, x2 square minus x1 square in the root. Yep. So this is the first formula. The second one is absolute difference, which is known as the Manhattan difference, which is x2 minus x1, the difference of these 2 points. And we have a more generalized formula, which is basically called as the Minkowski distance, where instead of 2, it's going to be a p. And this is root over p. So we can change the values of p as, if it is 1, it becomes the Manhattan formula. If it is 2, it becomes the Euclidean formula. And you can change the values of p, and you can work around with it. Okay, now that we understand what the algorithm of KNN is, we'll get into how we are going to prepare the data for this algorithm. Okay, so any doubts so far? Cool. Okay, the first thing is that scale data. So we'll be working with distances like you see. So if one data is of the orders of thousands and another data is of the order 0.001, then you can't compare, you can't find the correct distance between these two data points, right? So the first thing that you need to do is make the data scaled. You'll normalize the data. And the second thing is dimensionality reduction. So this whole thing that I explained is for one feature, which is basically one column of the data set. If you're going to have multiple columns, then this is going to be computationally very, very complex. So you need to reduce the number of features as much as possible. The next thing is missing value imputation. So even one value that's been missing, that can have an impact on the output. So you need to consider how you're going to treat the missing values. And the last thing is outliers. Like I said, this algorithm is very, very prone to outliers. So it correctly needs to be classified as an outlier, right? So that also we will look into it. Okay, what are we assuming in KNN? First is data is in feature space. Feature space is nothing but a Cartesian coordinate, if you can say, because we will be dealing with distances. So we need to know the exact value of x and y to calculate this. So that's the first assumption. The second assumption is that all these data points have some sort of labels, class labels to them. either like a positive association or a negative association, or it can deal with arbitrary number of classes as well. And the next thing is that similar things exist in close proximity. Like we will assume that there are no exceptions in the data set. Like, you get what I mean? So all the cats are together, all the dogs are together. So that sort of similarity within a class, inter-class similarity is assumed. What are the pros? So very, very easy to implement, and it's very versatile. It can be used in classification and regression. And a small variation of this, which is k-means, can be used in clustering as well. And the next, it gives very good accuracy for smaller data sets if k value is chosen properly. And it can also be used for nonlinear data. But the cons, like I said, is a lazy learner. It requires more time during testing. So it's okay even if we take the model, if the model takes time to train, but during the testing, we want the inference to be very fast. So that doesn't happen here. That's a problem. And if you're going to take large data set, like I said, it's going to be like very, very computationally complex. And hence the memory is also going to be more. And this is very sensitive to the scale in the data and the outliers. So we are done with KNN. So do you have any questions, any doubts? Cool. Okay. What is clustering? Clustering is basically similar set of group, like similar or a group of data form into clusters. So that's the idea of clustering. Example, if we take bank loans, they'll like cluster the customers into people with high income, people with a middle income or average income, and people with low income. Right. So what are the applications of these? Is we can do customer segmentation, like I told. We can do image segmentation. We can do document segmentation. Even the recommendation systems that you get in YouTube or in your Spotify accounts. So all this uses this clustering as the base. So, what is different from KNN and K-means? We do not have a target data to predict. There is no test point with which you're going to like do this algorithm, right? So we look at the data, try to find some sort of similarity between the data and how is it different from other groups. So that's why this is unsupervised learning. Like supervised learning, you'll give the data, you'll give the labels, ask the model to learn. But here the model needs to try to understand, try to like make sense out of the data that's thrown to it. So this is classified under unsupervised learning. Okay, just a second. Okay, so let's say this is one cluster. This is one set of cluster. This is another set of, and hope I have another color. Yeah, this is another cluster. So what are the properties that these clusters need to satisfy? The first thing is that all the data inside a cluster all the data inside the cluster needs to be similar. So you can't, like, if you're taking animal to be the cluster, you can have dogs and cats inside the cluster. But if you're classifying animals, then dog and cat should be in different clusters. So basically, the first thing that the cluster should do is that all the data points should be similar. And the next important thing is that between two clusters, there should be a lot of difference as much as possible. So I hope it's clear. So what are the metrics we use to find how good this algorithm is going to work? Like I said, in unsupervised learning, we don't have a correct and a wrong prediction, right? So we will use a different metric to evaluate the model here. So what inertia? So first thing is the inertia. What it does is that it calculates inter-cluster distance. Basically, take a centroid and calculate the distance from the centroid to all the points. So this distance should be very, very less. Okay, so that is the first metric, which is inertia. But like we saw, the clustering also cluster has two properties. The second property is that between two clusters, the value should be very, very large, right? So what the second metric does, done index, is basically it calculates the intra-cluster distance. So the distance between two clusters, and that should be maximum. So this done index is basically the minimum of the inter-cluster and the maximum of the intra-cluster. a ratio of these two, and the more the done index is, the better the model is. Okay, now how does k-means work? So the first thing that we do is choose a random arbitrary k, and then we select k random points as centroids, and we will assign the close. We'll calculate all the values, all the distance values to that centroid, and we'll see to this what are the points that are closest to this cluster, what are the points closest to this cluster, what are the points closest to this cluster, and we'll assign the values, right? And then once the clustering is done, we recompute the centroid. So the second set of centroids can be here, here, here. So again, this process continues. So this is done until convergence. So how do we understand convergence, or what is the stopping criteria of this algorithm? One is that either the new centroids that are formed, it does not have much of change. And the second criteria can be the points remain in the same cluster, like after every iteration, if the points are not changing clusters, then that can be considered as a stopping criteria. Or if both is not, like these two are ideal, if then this does not work, we can keep a maximum number of iterations as the stopping criteria. Okay, we've come to the theory end of the theory session. Do you have any doubts? Cool. So let's please open your Discord. I've sent the collab link and the dataset link. So if you can like download it and open the collab, we can like start the project. Tej bro. Any problem, any issues with accessing the collab or dataset or anything? Okay. So we are going to be using Google Colab, so because it's a free IDE to run Python program, and it's very, very effective. So two ways of uploading files to Colab. One is you can connect the Google Drive to it, and you can upload your data sets or something in the drive, and you can connect the drive to the Colab and use all the files. That is one method. Or the second method is that you can upload a file to the session, whatever it is. So you can just upload it directly. Right now we have the contents in the collab, so we're gonna like go ahead and do that method. So let's quickly run. It's going to ask for permission. We're going to give it. So once this is done, if you refresh it, basically all your drive contents, you can view it here. So we are in Spring, and these are the data sets. Yeah. So these are the two data sets that we'll be working on with today. Okay. Any doubts so far, or any issues with running the code or anything? Yeah.
Immediately go to the Google Drive. I already gave it access, but I'm not sure it's not.
Yeah. So the thing is, you have to upload it to your Google Drive. So the Google Drive that you're connected to, in that drive link, you can upload either that, or you can just download it and upload the file here directly.
Okay.
Yeah, this also you can do. Yeah, sure. Okay. So the first thing is we'll be importing from some libraries to help us work through the code. We're going to be importing pandas, numpy, matplotlib, and seaborn. Pandas and numpy will help you work with matrices, arrays, and everything. And the next two are going to be visualization stuff. Right. So the first thing is we are reading the data set using pandas. And here you will basically give the path of your data set. So how you give this path is basically there are three dots. If you see here, you can click this and you can give copy path. and you can paste it here. So that's how you access the data set. Shift enter will run the cell. And this is, yeah,
Can you backtrack a little bit?
yeah,
So after this, I already
yeah,
imported it, but I'm not sure.
yeah. So now this is your KNN data set, right? So you'll copy this, copy path, and you'll change this path. Uh, yeah, this is going to be the path. Now you give shift enter, this will run.
Okay,
Yeah,
thank you.
sure. So this basically dataset.head shows the first five elements, like first five rows of the dataset. You can basically like see how the data looks like. Like you can see there are some like missing values and yeah, all categorical values and everything. So the first thing that we are going to do is data pre-processing. And the first thing is we are going to check if any missing values are there. There are 13 missing values in gender, all this missing values. So we are going to be filling those missing values. What we're doing is we are taking that specific gender or the specific column, and we are going to use this function called fill NA. We're taking and we're filling with the mode of those values. Mode value 0. So that's how you basically fill. You can either use mode, and for here for loan amount we are using mean. So it's up to you. What do you think makes more sense? We can do that. So gender, it doesn't make sense to take mean of gender, right? It's a yes or no question. So in those type of columns, you're going to be taking mode. And loan amount is basically like a regression problem where you will have like point decimal values, and that's when mean makes sense. So that's how you fill the values. Now you see the data set, it looks better. Now, the ID column is not required. Like I said, for KNN, as much as, however, you can reduce the columns. If you reduce it, it'll be better. So we're going to just drop the ID column. And let's perform some EDA. What is EDA? We're going to like analyze the data, right? So run, run. Yeah. So this data has 614 rows and 12 columns. And here you can see everything is not null, and you can see the data type and yeah, basically the information of the data set. And we can check if there are any duplicate rows. We don't have any duplicate rows also. So let me explain one graph here, right? So what we are doing is we are using the Seaborn library to plot gender, which is the loan status. Loan status is basically going to be a prediction, the output value, and gender is going to be one of the feature. So when we plot this, we can see that so the blue indicates yes, the loan has been sanctioned, and the orange indicates no, it's not been sanctioned. So we have the graph for female and male. So from this, what can we infer? We can infer that on an average, male has more loans sanctioned compared to female. So that is an analysis or a conclusion that we can get. Male tends to get more loan than females, right? Let's take a quick break and let's try a small game. So if you all can log on to menti.com, we'll just quickly try to like have fun with and like see how much we've understood about the workshop so far. It's not going to be anything crazy. It's just like 5 basic questions. So don't feel free to uh, you can join using the QR code, or you can join on your laptop as well. Just go to the website and type in the code you should be in. I see people are joining. Is everyone in? Anyone is finding it hard to join or something? Cool. I guess we can start then. Okay, so I'm going to tell you what the questions are going to be. So I just showed you an example of how you interpret a graph, right? So we have male, we have female, and we have is if the loan is sanctioned or not. So those kind of graphs on other features, like other than gender, we have a lot of other features there. No? married, or things like that. So we're just going to go show you those graphs of the same data set, and we're just going to like try and find if we can analyze and understand what the graphs mean. Okay, let's move on. Yep. So you can see the graph. So it shows the loan status for married and unmarried. Voila, you're right. Good job. Next. So the loan stated was his graduation. Good job. Then we have credit history was his loan status. Even without the graph, we all know what the answer is going to be. So, but still, we got to analyze what the data says. Good job. Oh, sorry. I think the answer is marked wrong. But you all were right. Okay, I think the answer is marked wrong. Ooh, smart. Someone's very smart. The last one, I think. Property area. Are they from rural? Are they from suburban? Or are they from urban? Good job. Who will win? I don't know. I'm sorry. I don't know who the contestants are. Maybe next time we'll figure it out. But yep. Okay, let's move on. So I guess you understood how to analyze those graphs is very very important in any kind of uh, machine learning algorithm that you're trying to solve. The first thing that you need to do is understand the data, right? So blah blah blah. These are the things. So all the codes to basically see the graphs that you've seen in the game, I guess. You can see the codes to it here. Effect of education, effect of graduation, effect of employment, blah blah blah. Everything you can see here. So now, more than other, what other graphs can we infer? So we can see the number of people approved and not approved. So we can get the loan status and the value counts divided by the total number of rows in the data, which will give you the percentage of approved and not approved. And you can plot a graph to just for it to look good. That's all. And then Uh, we are a little short of time, so I'm going to skip a little bit about the graphs. So this box plot basically gives you these are the outliers, like I told. These vary like very much from the other data points. So you have to handle these things as well. So yeah, just some couple of graphs for you to analyze. If you have any queries, please feel free to ask. Okay, at this I'm not going to skip because it's important. So we're going to like choose which features contribute more to the output. So that is basically the correlation plot. So to this applicant income like correlates 100%, and to a co-applicant income, it does not correlate. It's negative 0.12. And so that's basically this graph. So how much correlation is there between one feature and the other feature? So from this correlation graph, we can conclude three things. Applicant's income and loan amount has high correlation, 0.57. Credit history and loan status also has high correlation. And loan amount and co-applicant income is also has the next higher correlation. Okay, now let's get into model building. We're going to use K-neighbors classifier. And another thing that you need to know is that the algorithms or any sort of model cannot work with categorical data. So you have to convert it into integer data. So we're going to give female 0, male 1, yes, no, everything. We're just going to There are other ways to do this, but for this purpose, I'm just going to keep it simple because then it'll open up to a whole new topic. So I'm just going to keep it simple here. You can create your own integer variables and you can replace it. So that's basically what this does. And if you can see now, there's no gender yes, no, it's just going to be zeros and ones. And your x is going to be your training set, which is everything but the loan status. And your prediction is going to be the loan status. So that's what we're doing here. Now we're going to split the test into X train, X test, Y train, Y test. We're going to keep the n neighbors as 5. 5 is a good amount to start with. And we're going to predict. This is the prediction. We don't understand anything from this. So for that, we're going to calculate the accuracy of the model. So the accuracy here is 65.58, which is not great, but it is a good starting point. So how do you improve the accuracy? Like I said, you'll go with the elbow method. You'll find the optimal K value, and that will help you improve the accuracy. So these are just like ways to see where at what instances did your model actually fail. So as you can see here, 403. The actual value is 1, the model predicted to be 0. And here. So this basically tells you where exactly your model failed. Maybe you can do something about that information. Yeah. So this is other metrics like confusion matrix. We'll have a discussion about metrics in another lecture, but if you have any doubts on this, you can like anytime reach out. So that's KNN basically. Do you have any questions in this code? Any queries? Any comments? Yeah.
Pretty new computer class in MBA. I wanted to ask, like, I know you said the trainers usually um you feed it a little for her kids. You don't feed it a little because it provides learning.
Yeah.
Okay, so it here you said sometimes you can pick up the loan status
Hmm.
dependent. Is that taking up the label? Can it both be with the label and without the label?
Yeah. Okay. I'll explain that. Just give me a second. So let's say this is your data set. It has feature one. Oh, I'm sorry. So it has a feature one, feature two, feature three, so on. And you have the final value y. So this is how your data set looks like, right? So you need to have two sets. One is the training set. Before that, one is the x and one is the y. So what are these x's and y's? So x's is x is basically the list of features we are going to consider. So we are going to consider if the loan is sanctioned based on a gender, based on marital status, based on graduation status, and so on. So all those features that needs to be taken into consideration to predict something goes onto your x, right? And the thing that you're going to predict goes onto your y. So that's why we are dropping that specific column from the training, like from the x, and we are taking that column to the y variable. Exactly.
It's like picking it out from the head. So you
Uh,
split the data like taking it out so that the train set can be taken.
yeah. So how are we going to like we into the model? We'll feed two things. When it's training, we'll feed the x train and the y train. So if you can see here, um, yeah, there is X train, X test, Y train, and Y test. There are four things. So when you feed it to the model, you'll feed the X train and the Y train. And when you do the prediction, you'll put only X test. And another, see another thing that I showed where you can like actual value versus predicted value. Actual value is that Y test. And predicted value is what we got from the model. Yeah, sure. Any other questions? Feel free to ask anything, like, wherever you are confused about. Okay, so let's go into k-means. So I'm not going to explain too much about it. So because I want it to be a bit of a homework sort of thing, if that makes sense. But like always, you can like ask out whatever questions you want. I'm just going to quickly go through this collab. Again, the first set we are connecting the drive. all this is same as the previous thing. And we're using the same, I think the same data set for this as well. Yep. Yeah. So let's just visualize. So this is how all the data points look like. So we're just going to take the value of loan amount in thousands. So this is the X and Y value of the loan amount thing. So this is how your graph basically looks like, all your data points in the graph. From this, we are going to try and form the clusters. So the first thing is finding the centroids, random centroids. So like if you can see the red dots here, those are the random centroids that's formed. And because we have given the clusters to be three, like A is equal to three, it's selected three random points, right? And then the next step, this is a bit of coding involved. If I get into the details of it, it's going to be a little long session. So what it basically does is while difference not equals zero. So this is the condition that it checks. If you remember in the elbow method, like to I told when the distance between two clusters is less or close to zero, that's when we stop. That is a stopping criteria, right? So that is the first that is the criteria we are incorporating here. So while the difference not equals zero, we are going to reiterate this process of finding the centroids and putting the points into the centroids recursively, right? So yeah, it goes through the centroids and finds the distance between them, and it basically reaches to a convergence. This is the training of clustering. That's all. Okay. Now let's just visualize how this is going to be. So your first cluster is going to be this second, third. So you can view this iteratively in every individual point. Like you can like basically paste this code here in this function. Yeah, if you paste this code in this function with every for loop, you can basically see how if different points are you know like put into different clusters and when it is converging. But it's going to take a bit of time. That's why I didn't do that. But so this is after converging. This is the final output that we get in clustering. So I think with that we are at the end of the workshop, and you get to take home two cool projects about classification and clustering. And if you have any doubts, please feel free to ask. If not, yeah, sure. Yeah. That's the first thing is you have to visualize the data, right? So if you see, like that's the first thing that we did here also. Yeah. So this is the Siddesh. Yeah. So with this, we can intuitively guess what would be the good cluster size. Sometimes the data makes no sense, so we might have to like change the cluster, like number of clusters, and like find out which would be the best case. And but a good starting point is basically through intuition, where you see the see the data how it is spread out, and then you like start with a specific k value. That's how you're going to do it. Okay. Anything else? Yeah. So all these resources will be put on the Discord channel, Siddesh bro. So they'll now we'll just project the channel's uh, QR code. You can join and you can access all these data sets and the collab. And I think we'll put up the PPT also. So yep, you can use them. You can find me also there, and you can like text me anytime if you have any queries. Thanks for coming, guys. Had a really good time. Oh yeah. Yeah. You can make a copy in your own drive, and you can make changes to that. I'll show you how if you have any questions. Come on, guys.
Stand beside you because you are tall. No?
Yeah, always at the back.
Always at the back.
Please,
Krisha, come.
president, ma'am.
Long
Long people.
Tall, tall.
Long people.
I think you should come to the front.
Yeah. You sit down. Sit down. Yeah, please.
Bro,
Come. Yeah, I will push this.
oh, thank you. आधा तो साइड में आधा
Thank you. So you are an undergrad or master's student?
I'm an undergrad.
Oh, cool.
I'm a
Which year?
freshman.
Freshman. Cool, cool, cool. Nice. You've joined the spring or?
No, I just came to check out the meeting, but
Okay.
I RSVP'd in case because I know it's required for most